Welcome, everybody, to today's session. My name is Stuart Walsh. I'm the Field Product Director here at SS8 in the Location Division. We take care of all things location for law enforcement, emergency services, and commercial and many other applications. Today's session is all about adhering to the latest emergency regulations, a regulation from the EU for mobile network location. I'm going to take you through a quick introduction, a little bit about our background and why we're relevant to this. And then I'm going to talk about the implications of government regulation, where it matters, talk about location technologies and the accuracy metrics that are in use, advanced location solutions to streamline the regulatory compliance. And then I'll talk about some deployment options and advantages to any network in that process, as well as potential commercial applications, which could be taken advantage of as well. So let me start with a brief introduction. So we've been in the location-based services business for over 20 years. We've been providing location for law enforcement agencies around the world on every continent and to emergency services worldwide as well as commercial applications, providing the highest and most reliable worldwide high accuracy location solutions for mobile networks, including standards industry like the Mintic in Colombia. We've also been involved as part of the European Help 112 program, where we provided architectural and best practice recommendations to help the location accuracy when AML was being initially designed. And obviously, we've helped the UK's first code of practice for location-based services as well. We're an advisory board member of ENA since 2011, so we're proud to be there. Especially as my background, my family, my father was in the emergency services, so I'm very proud to be a part of that, as well as providing expertise to the UK Home Office. So really our background is all location and providing location to governments and to mobile operators. So let's kick off. The implications of the government regulation and to recommendations for public safety. This has been in the works for a while, going way back. Actually, I think it started probably around 21, 22, but in 2023, as part of the delegated regulation, EU 2023-444, caller location accuracy is to be improved using a combination of handset and network-derived caller location. So what they wanted to do was to continue to improve. So one of the things that all emergency services clamber to governments is to improve the technology constantly, keep using new capabilities to be able to save lives effectively. And what they wanted to do is to improve both network location and handset location, bring those together so that you can bring the absolute best location to the emergency services. And that was driven by this regulation. It was out for discussion, and the whole idea was that to make sure that governments are aware of the capability and that they are discussing it with their regulatories and their operators about implementing these solutions. The organization driving it is ENA, the European Emergency Number Association. So they put a recommendation forward in conjunction with the EU. And that recommendation states that the criteria should be that around horizontal accuracy of an estimate of 50 meters for 80% of all mobile originated emergency calls. Now, if you set the context for that, more than probably 8 or even 90% of emergency calls now come from mobile handsets. So ensuring the highest quality and best accuracy for calls that are on the move or that aren't at a register address is now become a big focus for the regulatory organizations and organizations like ENA that want to keep striving forward the whole propositions around location and emergency technologies. So the latest update, as of the 5th of March, so very recent, that marked the date of the deadline for the EU member states to report to the European Commission. So if you can imagine, it's been going through a consultative period, and now countries have been asked to put practices in place to start complying with this new regulation. The criteria will be adopted at a national level for accuracy and reliability. I'll talk a bit about that later on. But the whole idea is to provide that location information for emergency communications, not just from mobiles, but also from landlines. But the focus really was on mobiles since, most emergency calls are coming from mobiles. And at this point now, the focus shifts to monitoring and enforcement. So I want to talk about that. So the accuracy and precision. So that's the first thing. If we took a little bit of history for this, historically, the automatic provision of location has gone from providing either an address. If you can imagine, historically, you would have called from your home address or from a business address. But now with mobiles, the mobile networks involved, and you need to be able to provide a high accuracy, high precision. But if you don't measure it, you won't be able to manage it. So you won't be able to say how good is your accuracy and your reliability as a government to the EU if you don't measure it. So some of the practices in place are around PSAPs themselves, checking the call was located correctly. This can be cumbersome and also can be quite costly because the prime purpose of a PSAP, which is the public safety answering point, that's the call center that takes the emergency call, is to actually take emergency calls, not to be doing this process. So some countries have looked at providing drive testing, and drive testing is where someone or a group of people drive around the countryside in cities, urban areas, rural areas, and take measurements, and they will place test emergency calls and see how they were located. That is extremely expensive and time consuming. But again, one of the practices that is being used. It is being used by mobile networks themselves, so they can combine that as well as doing testing. So they will do if you're in an area where you want to improve the service and the mobile network wants to be able to try and do that, they would enact drive testing. But one of the most powerful mechanisms is to use the mobile network measurement system themselves. So the mobile network can actually be used to measure how accurate a call was. I'm going to talk about that a little bit. But it adds to this list of capabilities so that you can actually measure what kind of accuracy and precision and reliability that you're providing for emergency callers. So what many countries have done, and this has been done in the Americas and US kind of led this, is they've set a table like what you're seeing here. And this isn't necessarily what every country would apply, but this is just an example where they would say, all right, well, how many calls have achieved under 50 meters or up to 200 meters? And you'd expect that to kind of expand as you go out into rural and remote areas. But the whole idea is to set these measurements, measure them, monitor them, and that will give you the capability to be able to say, yeah, we're actually complying with this new regulation and improving and saving lives. But it's not an easy process, and that's why I think it's quite important for everybody involved in this, whether you're a regulator, a mobile network, or a government person, or a person involved in emergency services, to start thinking about how this will be done. So let's talk a little bit about cell and subcell location technologies, since I'm talking about the mobile network, and the accuracy metrics currently in use. Now, the oldest mechanism in use would be what we call a cell location. So whenever you place a call, such as an emergency call to a network, your cell location would be provided. Now, it might be that you're in that area, so you can see the diagram that I'm showing there, and it would provide the emergency services saying you're in that area. And that would vary greatly depending on whether you're in a dense urban area or a rural area. But it was useful, and it did help emergency services, but not to a really big expanse. Even my own father, who worked in emergency services, said, I wish I had something better. And unfortunately, he's passed on now, but he would love the kind of next technology which was introduced, which was AML. Now, AML is advanced mobile location. And effectively what it was introduced now in the last couple of years, and most countries in Europe have now implemented it. And it helps when you place a call, the phone will go into an emergency mode and it will do everything it can in order to locate you. It will use the GPS, it will use the cell information, it will use Wi-Fi, even uses barometric pressure if possible. It will use many techniques, which has been primarily driven by Google and Apple. They're really trying to improve their phone's capabilities around emergency location. And when you place, whether you're in Europe, you press a 112, in the UK 999, or 911 in America, that phone will go into that mode to try and locate you, which is very, very powerful. And it really has helped revolutionize and save lives. So this constant technological improvement is something that the industry needs to keep looking forward. And AML was a big, big leap forward. But there are limitations. AML's success rate varies greatly around the world, especially here in Europe, where you have variation from, getting 30% of calls successfully located with a good location to some countries getting 97% plus. And the cell location, as we've seen, can be a really large area. So if it doesn't get what it needs from the handset, it may only have to rely on the cell location. The problem with all of this is there's no reliable audit trail. The mobile network, the mobile handset manufacturers and the operating systems such as Google, Android, and Apple iOS, they provide this as a goodwill service, but there isn't really, shall we say, a trace of how well things have actually worked. So one of the challenges you have is when you want to go and do an audit or do some sort of monitoring, as I've said before, it's a bit of a challenge. And some European countries have spent a lot of time and effort to try and measure, because, as I said originally, unless you can properly measure something, you can't manage it and you can't produce some results to report that to the EU. So really what you need to look at is to improve these techniques. And one of the best ones is using advanced location. Now, advanced location is where we're using subcell technology, and it'll help streamline regulatory compliance. It'll help drive up that position accuracy and reliability, plus also introduce the capability to audit. Now, subcell, as it's known sometimes in the industry, or high accuracy network location, it's been around for a while, but it really has improved in recent years. As I said, originally, you would just get a cell location, and that would be an area, could be 500 meters in a city, could be 25 kilometers in a rural remote area. Over the years, that's got better with timing advance and other metrics. But now with advanced techniques, geomultilateration, we can actually get down to high accuracy capabilities of 50 meters and less. And that means combining that with the handset AML capability, you're giving yourself the best possibility in order to be able to derive an accurate, precise, and reliable location. The good thing is this technology is all standards driven, and it's available in every mobile network. Obviously, it would have to be set up, but it's not introducing new technology. It's just enablement that needs to happen. Just a little bit on how this technology works. The high-level overview is that we start, obviously, with a location of a cell, which is historically what you get from a mobile network. And then what you can do now is you can use an intersection. So at a very high level, sometimes people use the word triangulation, but that's not technically what happens. What actually happens is an intersection process is driven through algorithms where we get neighboring cells. All those neighboring cells, as you know, with a mobile network, you're not just attached to one cell, you'll be listening for lots of other cells as you move around, and they'll be gathering metrics, and those metrics are available, such as timing, power, and many other pieces of data, which can help derive that subcell high accuracy network location. And that high accuracy subcell network location is key, we believe, to helping with improving your accuracy in complying with this new regulation, because you can get a much broader capability. It's independent of the device. It's independent of the type of OS you have, and it definitely improves those percentages. We've seen countries around the world where they've introduced this, where they have had very low compliance with regulation around emergency location, and they've been driving that up towards the 90% percentile, which is saving lives. And that's one of the key responsibilities of a government and emergency services. Powerful thing is, it doesn't just help you comply with government regulation, it also helps you comply with commercial use cases. So we've seen in places around the world where they've implemented this technology to help save lives for regulation purposes, but then it can be utilized for commercial use cases. So that's always very powerful, because mobile networks, they're commercial businesses, they're run to provide their shareholders value. So by providing commercial use cases, it makes it even more beneficial. And one of the things we've seen in recent years as well is using network location technology, you can help service improvement. You can actually identify where there are service area issues, and you can be very, very precise in what areas what issues are causing problems in specific areas. So this really does benefit mobile networks. A little bit around the deployment options. So key to you got to be able to measure this, but you got to put it into the network. And it's all standards driven. Now it's very much a software only driven architecture. It's 3GPP, which is one of the biggest standards organization for mobile networks today. And it can be deployed in any form, whether it's traditional hardware like HP, Dell, Supermicro, and many other pieces of off-the-shelf hardware, or more now, mobile networks have virtual or cloud environments. Because it's a software, because it's standards compliant, it can be deployed easily into the mobile network in order to derive these benefits. The deployment model is being driven down because of those standards. There are multiple vendors with the capability to do this. All of them, the big mobile network vendors like Ericsson, Nokia, Huawei, and some of the newer ones have all signed up to 3GPP standards. So it's not like you have to introduce new technology into the network. And they've been implemented all around the world, not just here in Europe, in the US, in Latin America, and in Asia. So it's quite a mature technology at this point. And it can be relatively straightforward if the network is signed up to put these in, because of the standards-driven approach. All of the interfaces are there. They just need to be switched on and licensed by the vendor. And typically, a lot of networks will already have technology, possibly what's called a GMLC, a Gateway Mobile Location Center, for providing that cell level. So all you're doing is adding another component to the network. There's no additional bespoke hardware, as I said. And now with cloud and virtualized deployment, it accelerates that process, typically shaving 50, 60% of the delivery time, where it would take maybe years to deploy. It can be deployed much quicker now. And that really has helped networks and governments employ these to help ultimately comply with the new regulation. So again, one of the things we always get asked is, can it be used for commercial applications? And absolutely, we've put these solutions in around the world where we set priority given to the emergency services. That is always got the highest priority, but then it can be beneficial for commercial use cases around transport, for retail, for media, for property. Location is a huge thing now. The many companies have already seen this, but mobile networks, because of their capability of being a fixed network with known locations, they can provide a very highly detailed and also now very high accuracy location, and sell that business location information, obviously highly anonymized and fully GDPR compliant, to their customers. So the whole idea is that not only are you complying with governmental regulations, such as what I've just laid out from the EU and the new deregulation and the new regulation, you can also make commercial cases as well as complying with law enforcement and improving your network capability. So really, at this point, I'm going to hand over for some questions. Again, I'm Stuart Walsh. So my contact details are here. We'd love to hear from you on any challenges that you might be encountering now with this new regulation gone live as of 5th of March. Have you been approached for this? What kind of questions are you being asked? And there's always been challenges. I've sat in front of European regulators meetings, seen the kind of objections and trying to move all of this forward towards this regulation going live. But I understand there's still a lot of education to go forward out there. So I think we'll hand it over now for some questions. Annie.
Hello. Well, Stuart, that was interesting. And we've got a question for you. And just a reminder here, we're being asked about whether content's available later. Yes, all of the video sessions will be available on demand within a few days. And we will send the link to everybody who's registered, because that was another question. Right, let's get to your question specifically, Stuart. And that is, with the advent of new technologies such as 5G, how about regulations for vertical positioning? That's the Z-axis. So obviously for tall buildings.
Yeah.
Or are the regulations, currently limited just X-Y axis, so horizontal?
Brilliant question. Brilliant question. So at the moment, the regulations is on horizontal. So it's your typical XY axes, which is what we're all familiar with. Google Maps, Bing Maps, OpenStreetMaps today. It is a coordinate on a map, but it's a 2D coordinate. And this is what this regulation focused on. Actually, as is quite often these days, the Americans are ahead of us on this, and that the FCC has put a regulation for vertical 3D access. And it is something that the Europeans are starting to look at. I've actually spoke about it at the European Emergency Number Association regulation previously, and it is something that internally is being considered. The challenge you have is that obviously 5G, and especially to do with beam formation, is key in order to enable that. And that's got to be prevalent everywhere in order for that to become a reality. Now, we've actually started launching some solutions here in Europe with full 5G standalone. And then we're looking at networks that are implementing these beam formation and seeing how widespread that will be. But it will definitely be a focus in the coming, I'd say, 1 to 3 years. And you will start to see that kind of regulation. One of the challenges you have is comprehensive 3D mapping. So one of the things that if you talk to the US about where they've been jumping through this for nearly a decade, and it's a real big challenge for them. So what we want to do is learn from all of the challenges that the US has gone through and make sure we don't fall into the same pitfalls. As I said, one of them is 3D mapping, because it's fine to say a person's 20 meters vertical, but where is that and what building is it in? And that needs to become very standardized, very open standards, whereas at the moment it's kind of, very fragmented. But that's something that will change. Absolutely.
Okay. And have all the EU member states reported on their progress in meeting this regulation, Stuart?
It's coming. So as of the 5th, they were to start that reporting process, but you will fully appreciate that things in EU, such a large organization, take time. So those results will start coming through. I haven't seen them myself. If anyone has seen a report, let me know. But they will be published. The best place to look for them, because a driver is at ENA, so ENA.org.
Yeah.
And look for any reports that come there. But definitely it's something that I will be looking out for to see how governments are complying. We are, obviously, I can't disclose which ones, but we are working with governments on making sure that they comply. But it's really only a start of the process. If you can imagine, in 22 and 23, it was all about hey, look at this new regulation we're going to put in. As of the 5th, it's now gone live. So countries have to start applying their own rules. A few countries, like Romania, as an example, have actually put things into law, but we'll see more and more countries starting to do that, I think, in the next year or less.
Okay, so why is network location more auditable and measurable than AML?
It's really to do with their nature. So AML is a service provided by Google and Apple, and they, in order for them to provide a full audit, you would have to strip apart the operating system, in other words, to see what it does. And they don't want to expose that for real reasons. It's internal reasons, for their own patents and their own capabilities. So they provide a certain level of information. But with a mobile network, it's very standards driven, especially around 3GPP. So everything they do is logged. And carefully logged. So one of the things that we provide along with emergency location is law enforcement location. And you can imagine if I'm producing a location for locating a criminal, either historically or real time, I've got to be able to prove that. And the mobile network logs everything. So the algorithms that are used are logged, how that's done. It can both be presented visually and in a table to say this is how it was worked out. So you can get really detailed information about how that happens. But with AML, it's a best of service provided by Apple and Google. They don't make available those logs.
So those services are a kind of best effort and without an evidence trail and a permanent record of.
I'm not sure if anyone's here from Google. They would like to say it's better than best effort, but those words are effectively there. They don't charge typically governments for this. It's a goodwill gesture by Google and Apple, which we really should appreciate because it has saved lives. That's a fact. But yeah, it's a goodwill gesture, and it would take a lot in order to be able to diagnose. Imagine having to diagnose every single call, whereas they don't kind of do that at the moment from an exposure perspective.
Okay, I'm wondering if you could mention, Stuart, a couple of some other commercial applications for this location service, because it seems to me it's one of those things, the more you think about it, the more occurs to you, really.
Yeah, absolutely. When we see that throughout the world where we put these solutions in, where initially it would have been put in for emergency services, or it might have been put in for law enforcement, and the network is looking to ways to get money out of it, because sometimes the government just says, well, just go and put it in network on your own cost. And if I'm managing a mobile network, I'm going to go, well, I want to get some money out of this. And you can with a commercial. One of the biggest ones we're seeing is fraud. Fraud is a huge.
Presumably anti-fraud.
Yes, anti-fraud. I'm talking about you're absolutely right. I'm talking about anti-fraud, but it's around the fraud. It's the ability to be able to both detect fraud and prevent it. So one of the ones that a lot of work has been done is around a service in Africa called mobile money, or MoMo short, where they use mobile network text, kind of USSD messaging in order to pay for things. And you'll see these little booths all over the place if you go to African countries. It's been very, very successful because they obviously they're emerging countries, but fraud was a huge part for them for people sharing. You can imagine mobile money and being able to detect that the customer and the agent are in the same location. And that technology can be applied. So many banks have looked at that. Example here in the UK, many of the big banks want to be able to use location technology to carry out the fraud detection, and do it both preemptively. So if you're doing a large transaction, checks can be made that it makes sense where you are and what you're doing. And the same when you're trying to review a transaction previously. So we want to get some evidence about where that transaction might have taken place and where you were. There's a hell of a lot. There are many other areas such as mobile advertisement, genericizing information for what we call location analytics or location insights. There is a huge area on this. One of the most successful ones give a shout out to a commercial application in the UK called O2 Motion, and they do location insights.
Okay, can you just give me like one example of what you mean by location insights?
So location insights is where the mobile network will gather location information. It's heavily anonymized, very compliant with GDPR, so they don't share people's locations. But give an instance where they want to see where to place advertising in a station.
Okay, gotcha.
So you want to be able to say, I want to know which entrance is used the most or exit is used the most, and that's where I want to put my my advertising. The same when it comes to like real estate, where you want to be able to get location insights on transport hubs and area knowledge, and all of how people travel around that area, and it expands out from there. Hopefully that makes sense.
Yes, certainly. Stuart, thanks a lot. That was really interesting.
Thank you very much.